Okay, the factored form. In just a few minutes, I'm going to attempt to help you completely understand two super important things about it. Number one, what's so useful about it? And number two, how to obtain it. So let's begin with the standard form of a quadratic equation. I will show you a trick known as the cross method. Let me show you how it's done, and I promise you it will be crystal clear. So this is our quadratic equation in standard form. Y equals to x squared plus 5x minus 24. If you think that this is the factored form, then you are right. So let's see how we can obtain this answer right here. The method I'm going to show you is known as the T method because it looks like a T shape. So notice there are three terms right here. Term 1, 2, and 3. We have to make sure that we get the three terms in the last row in such a way, right? Where this x squared, this negative 24, the third term, and this 5x. So the first term in the T method corresponds to the first term here, and the second term in the T method corresponds to the third term, and the last term corresponds to the second term. Okay, how do we go ahead to get the first term x squared? We multiply x with x and check. Of course, this will be x squared, right? So that's done. Okay, to get negative 24, we multiply the factors of negative 24, which could be negative 1 and 24, 3 and negative 8, 6 and 4, 6 and negative 4, or negative 3 and 8. Okay, using negative 3 and 8, when multiplied, it will give us negative 24. Okay, so negative 3 and 8 is fine. Okay, then what we're going to do next is we cross multiply x and negative 3 and x times 8. So this will give us negative 3x and 8x. Okay, so to check if we get 5x, we just add negative 3x and 8x and check, right, if we can get the second term. So yeah, indeed, we can get 5x, right? So the T method is done, okay? So what's so useful about the T method is that we can just read off it to obtain the factored form. So what I mean is x minus 3 and x plus 8 is the factored version of the standard form. Okay, so we can express the standard form as the following factored form, which is x minus 3 and x plus 8. So y equals to x minus 3 and times x plus 8 is the factored form of the standard form. Okay, and that's how we convert the standard form into the factored form. So we are done, right? The very last thing I would like to touch on, which is extremely important, is how to apply the factored form. So back to the initial question and solution. This was our standard form right here, and this is the factored form. Okay, of course, we're going to focus more on the factored form. Basically, this is the quadratic graph. Okay, what's so useful about the factored form is that we can obtain the roots or solutions or the x-intercepts of the quadratic graph by reading off the factored form. Okay, so we simply equate the first bracket to 0, and we get x equals to 3. So x equals to 3 is one of the solutions or x-intercepts of the graph, which is over here. Okay, similarly, we equate x plus 8 to 0, and we get negative 8 as the other solution or roots or x-intercept of the graph. Okay, so just to be very clear, whenever we say root solutions or x-intercepts, they're all the same, right? So I'll just call it the x-intercept for clarity. Okay, so this is negative 8. Okay, secondly, right, we can use the roots or the x-intercepts to obtain what is known as the line of symmetry. So what is the line of symmetry, right? The line of symmetry basically cuts the parabola or the quadratic graph in half. Okay, so for example, this is our line of symmetry right here. Can you see? It cuts the graph into half. So how can we obtain our line of symmetry, right? Okay, to do so is very straightforward. What we do is we just add up the x-intercepts. So for this example, it will be 3 and negative 8. Okay, and then we divide by 2. So x plus negative 8 over 2. That gives us negative 5 over 2, which is negative 2.5. Okay, so this line of symmetry right here is located at negative 2.5. And yeah, of course, the y-axis will not be here in this case, right? The y-axis will be somewhere a bit towards the right of the negative 2.5. And if you think about it, the negative 2.5 refers to the x-coordinate of the vertex, or the turning point. Okay, the turning point of the graph is where the graph begins to turn. Okay, so this one in red is the turning point of the graph. The x-coordinate of that turning point is negative 2.5. Okay, so let's just take note. The x-coordinate of the turning point will be negative 2.5. So how can we find the y-coordinate of the turning point? Right, to find the y-coordinate of the turning point, we just have to substitute the negative 2.5 into the standard form or the factored form. Both ways work. Okay, so doing that will give us a value of negative 30.25. Okay, so putting everything together, the factored form allows us to find the x-intercepts of the parabola, and using the line of symmetry, or the x-intercepts, we can find the x and y coordinates of the turning point.